All right, section 4.1, we're looking at a probability distribution. Okay, first thing we're going to talk about, now this is from the book. This is a copy of the textbook, which you're able to get this from every problem. You can look at the textbook. Anyway, what we have on here that we're going to look at is a random variable. A random variable represents a value associated with each outcome of a probability experiment. Like you have an experiment, like whether it's rolling dice, or whether it's flipping a coin, or whether it's seeing how many cars hit a pothole going down a road. Okay, this could be a random variable. All these things could. And there's two types of random variables. You might want to maybe take a picture of this or write notes down. But you have discrete and you have continuous. Two different kinds of random variables. What's the difference? A discrete is a finite or accountable number of possible outcomes. Continuous is when it's infinite. Where you, there you go, infinite. Or uncountable number of possible outcomes. This helps explain it right here if you look at these number lines down here. Okay? This one right here, this is discrete. We have just these individual values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What this represents now, the number of calls that you might get in a day. Okay? There's no way, the reason thing here is there's no way to get 3.5 calls. You know, there's no way to get 4.67 calls. This is discrete, and it's a finite number, which means you can count them, and you get to the end of that count, and that's what it is. Whereas here, hours spent on the phone. Hours spent on the phone. This is continuous, which means you can spend 6.2 hours, 6.9 hours, this is 6 and 9 there. But anyway, there's split minutes you can spend on this. So these are not just these values, 0, 3, and all these. There's all these values in between them. And you can't count all the different values because it's infinite. That's what a continuous random variable is. Okay? Now let's look at a couple questions here. Let X represent the number of Fortune 500 companies that lost money in the previous year. Is that discrete or is that continuous? Well, you can count up the number of Fortune 500 companies. So this would be discrete. Okay? Now, what about this one? Let X represent the volume of gasoline in a 21-gallon tank. Now, that's continuous because it could be 5.8 gallons. It could be 7.34 gallons. It could be 6.884227 gallons. Okay? So there's so many different possibilities it could be, and it's infinitely many. You can't count them all. Okay? Now, try it for yourself down here. Let X represent the speed of a rocket. All right, that would be continuous because there's so many possibilities of the fluctuation of it. Too many to count. Let X represent the number of calves born in a farm in 1 year. All right, that's discrete because you either have 1 cow, 2, 3, 4. There's no in-betweens, and so you can count those real easy. Same thing here. Let X represent the number of days of rain for the next 3 days. How many times is it going to rain the next 3 days? Okay, the number of days that it rains. All right, that's discrete because you can count those 1, 2, or 3, or 0. Okay. Now down here, we're looking at what is called the discrete probability distribution. Okay. And what this is, there's two things to look for a discrete probability distribution. One, and this right here, P of X, this is your probability of X event, whatever X is. It's got to be between 0 and 1. Okay, no ifs, ands, or buts about it. It can't be negative and it can't be greater than 1. Then the sum of all the probabilities, all of them all together, has to equal 1. And you got to have these two things for it to be a discrete probability distribution. Okay, so look at this one here. Okay, we have An industrial psychologist administered a personality inventory test for passive-aggressive traits. Let me get it down here a little better. To 150 employees. So there's 150 employees. If you add these up, 4 plus 3 is 7, 9, 10, carry the 1, 3, 6, 10, 13, 15. You get 150 when you add these up. Okay? Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. You might have filled out something like this before, where you're rating something of yourself. A score of 3 indicated neither trait. The results are shown at the left here. Construct a probability distribution for the random variable x. Okay, and then graph the distribution using the histogram. All right, so what we're doing here, okay, the probability of 1, well, there's 24 of those out of 150, and that's the probability of 1. Probability 2 would be 33 over 150. Okay, and you can see all those down here. Okay. And so by doing so, see here, there's 0.16. The probability of 1 is that. So I have 1 and I have 0.16. 2, here's 2. When I do this probability, I get 0.22. See those right there? And 3, 4, and 5, so on. And this right here is called a probability distribution. Okay? If you add all these up, it will equal 1. If you notice, each one of these is between 0 and 1, so it all checks the boxes like it's supposed to. All right. Now here's one here. Verify if this is a probability distribution. All right, so look at your individual probabilities here. Okay, they're all between 0 and 1, so that's good. All right, now you add them all up. Okay. All right, if you add them all up, it shows it right here. Add them up, it equals 1. So it is a probability distribution. Okay. What about these? Are these probability distributions? Well, I noticed right off this one's not, because there's a -1. That one's not. Okay, now if I add these up, according to this, it adds up to 1.07. So it's not, because it adds up to more than 1. It does not equal 1. It has to equal 1 to be a probability distribution. Okay. Now, finding the mean of a probability distribution. Of course, mean is average. Finding the average. And of course, mu, this is the little symbol. This is mu, is how you say this. Mu, with the U there. My pen's mu. Okay, this is mu right here. That's the mean. This is a symbol we use for the mean, which is the average. Okay, now how do you find that? You take each one of these and multiply them. So I do 5 times 0.14, I do 4 times 0.20, and so on, and I add them up. So you see down here in this little table, 1 times 0.16 is this, 2 times 0.22 is that, and so on. Here's all these up, and you take these and you add them all up. And that's what this is saying right here. This is math documentation here to represent what we're talking about. Sigma means you're adding up all the sums, and this is x times p of x. Okay, see here's x and here's p of x, and I'm multiplying those. And this means I add all them up. That's what this means. But anyway, so mu, my average here, is 2.94 once I add all these up. Okay? So that's what the mean is. The mean is when this means the sum, you add up all the x's times their probabilities. Okay? Now we'll look at some of these problems. All right, first off, we got some terminology stuff. What is a random variable? Okay, a random variable. The answer is B right here. The outcome of a probability experiment is often a count or a measure. Then when this occurs, the outcome is called a random variable. Okay, that's straight from the book. I think it was on this first page. Right here. Yep, right here in from the book. Very first sentence. Okay. All right. So that's number 1. Number 2. What is a discrete probability distribution? What are the 2 conditions that determine a probability distribution? All right, we just talked about that. They've got to be between 0 and 1, and they have to all add up to 1. Okay. Okay, all right, what is the discrete probability here first? Okay, so what is a discrete probability? All right, the answer is B. A discrete probability distribution lists each possible value, a random variable. It's cut off here what the writing is. That's can, assume, together with this probability. A discrete probability distribution is this right here. You got X and you got P of X. You got 1, 2, 3, or 4, or whatever your numbers are. And then down here's your probabilities. And so a discrete probability distribution has a list of all your X values, the possible random variables, and its probabilities. Okay? Now down here in part B, what are the two conditions? That's what we talked about just a minute ago. So the answer here I think is C. The probability of each value of the discrete random variable is between 0 and 1. And the sum of all the probabilities is 1. There's your answer right there. Oh, I'm sorry. I just realized it wasn't on the screen. There's my two conditions. Okay, that's important to know. Okay, number 3. Okay. Is the expected value of a probability distribution of a random variable always one of the possible values? All right, now the expected value, we're going to talk about that more here in a little bit, but the expected value is what your average is. Your average is your expected value. That's another name for it. Okay, so is your average going to always one of the possible values of X? No, it's not. Now, when you find average, your average, if you just do numbers, your average doesn't always have to be one of your numbers. It could be like, and more than likely, it has a decimal part. So the answer is D, no, because the expected value may not be a possible value of X for one trial, but it represents the average value of X over a large number of trials. So it may not necessarily be one of those values. Number 4, what's the significance of the mean of a probability distribution? Okay, and that's what I just told you there. It's the expected value of a discrete random variable. The mean is the expected value. Okay. Number 5, determine whether the statement is true or false. All right. In most applications, continuous random variables represent counted data, while discrete random variables represent measured data. All right. These are backwards. Yep. These are backwards. Continuous is measured. Discrete is counted. So this is false. It should be the other way around. And that's what this is saying right here. Number 6, determine if it's true or false. The expected value of a random variable can never be negative. Okay? Now, this statement is false. It can be negative sometimes. Your average, your expected value could be negative. I don't know if we'll have one like that, but it is possible to have a negative expected value. Okay. Number 7. Decide whether the graph represents a discrete random variable or a continuous random variable. All right, the home attendance for football games at a university. So we have these home attendances. This looks like it's discrete because we can count up the different numbers and there's a finite number. So this is discrete. Okay. See, it's not uncountable. If it's continuous, it's uncountable, and you can count up the different attendances, even though it's a big number. Number 6, decide whether the graph represents a discrete random variable or a continuous random variable. The distance a baseball travels after being hit. Okay, you could bunt the ball and it'd go 5 feet. You could hit it 30 feet, 35 feet, 35 and a half feet. This is continuous. So this is B, continuous. Okay. Number 9, determine whether the random variable X is discrete or continuous. Let X represent the number of points scored during a basketball game. All right, these points are countable. So that means it's discrete. All right, so it is discrete. So A or B, discrete, okay? because it has a countable number, not an uncountable. No, that's not right. It's countable. It's A. All right. Number 10, decide whether this is discrete or continuous. Let X represent the time it takes to run a mile. Okay, the time it takes to run a mile. All right, some people might run a mile in, like world record is 4 minutes. Some people might run a mile in 5 minutes. Some people may run a mile in 12 minutes. But then somebody might run a mile in 5.54 minutes or 5.57 minutes. These are uncountable, all the different ways you can run a mile. So this is continuous because it cannot be counted. Okay. Number 11, decide whether this is discrete or continuous. All right, X represents the number of motorcycle accidents in 1 year in California. All right, those can be counted. You can count up, hey, there was this many accidents. So this is discrete. Okay, the difference is if you can count them or if you can't count them. All right, number 12, decide whether this is discrete or continuous. X represents the volume of milk taken from one cow for a day. All right, so a cow may give you 1 gallon. A cow may give you 1.2 gallons, 1.23 gallons, 1.24 gallons, 1.247 gallons. This is uncountable, so continuous. Can't count up the different ways. Okay, now look at number 13 here. A frequency distribution is shown. This is a frequency distribution because you have your X here and you have your number of households down here. All right. All right, so this is the number of televisions per household in a small town. So there's 25 people that have no televisions. Okay. This says use the frequency distribution to construct a probability distribution. Okay, so what we're going to have to do is we're going to have to take these right here and we're going to have to add them up. All right, so I got my calculator here, okay? All right, so I got to do 25 plus 441 plus 730 plus 1,402. And that comes up to 2598. Okay, that's what all these add up to. So my probability right here, I do 25 divided by that. 25 divided by 2598 comes out to 0.0096. It doesn't say, yeah, around 3 places. So this is going to, the 6 makes the 9 go up to 10. So it's going to be 0.010. Okay. Number 2. Okay, there's 441 divided by that. 441 divided by 2598 comes up to 1697. The 7 makes the 9 go up to 10, which makes that go up to 7, so 0.170. Okay, and then 730 divided by that, so 730 divided by 2598 comes up to 2809. The 9 makes the 0 go up to 1, so 0.281. And then 3 right here, 1402 divided by that. 1402 divided by 2598. And that's 5396. The 6 makes the 9 go up to 10, which makes this go up to 4, so 0.540. And there you go. There's my probabilities. Okay. This is my probability distribution. Now this one's going vertically instead of horizontally. Most of the ones we've been seeing so far, this will be 0, 1, 2, 3, and then my probabilities will be down here 0.010, 0.170, 0.281, 0.540. See, this is horizontal. This is vertical. This is vertical. Okay, so it could be either way. Now it wants us to figure out what the graph looks like on this. Okay, so so what we look at is our probability. See, these are the number of televisions and then the probabilities over here. Okay, so on this one, if I look at 0, it should be 0.10. Okay, see here, 0, this is This is way out right here. This is off. See, 0 should be 0.10. It should be like this right here. See, both these both have my 0 right. Now let's look at the 1. 1 is 0.170. All right, so at 1, 0. Oh, look, this is above 2. I think we should be right here. 0.170 right there. I think this is C is my answer. And it actually got kind of cut off. Okay. Now, what this is called here, this is describe what this histogram is. Here, I'll show you what the answer is. Here's the answer. And this is called skewed left because, see, the tail is on the left. Okay, if it was like this, and you had your tail this way, this would be skewed right because the tail, you look where the tail is, left or right. That tells you how it's skewed. Okay. All right. Number 14. Okay, the data given below shows the number of overtime hours worked in 1 week per employee. Use the data to complete parts A and B. Okay, so it wants it to construct a probability distribution. All right, so we have our numbers here, 1, 2, 3, and 4. And it should go 5 and 6, so 5 and 6 got cut off. But what I'm going to do is, for 0, I'm going to do 5 divided by, actually they go further, so I can't do that. Oh no, that's right. 5 divided by 185. Okay. So I type it in there, 5 divided by 185, and that comes up to 0.027. It says round 3 places, so 0.027. And then I do right here, 13 divided by 185. 13 divided by 185. It comes up to 0.07. The 2 makes the 0 stay. And then so forth. That's how we do this right here, 32 divided by 185. And that's going to be 0.172. The 9 makes the 2 go up to 3. 0.173. And so on. I'll let you guys do these on your own there later. So that's probability distribution. And it says draw the correct graph for it. So we can graph it just by the 3 we have here. So at 0, it should be 0.27. All right. I think it's more like this right here. See there, because here's 0.1. This is 0.027. See, this is a little bit higher. This is almost 1, where this is closer to 0. So I think the answer would be B here. Now, what is this one here? Now, this one here is approximately symmetric. To see how it's kind of the same on both sides, it's close to being symmetric. It doesn't really have a tail because this side's going down over here. I'm sorry, this side's going down over here too, just like that side is. And we got the big ones in the middle. So it's kind of symmetric, kind of. So approximately symmetric. Okay. All right, use my probability distribution. Here's my probability distribution right here. Okay. All right, now this says, find the probability of randomly, all right, hold on. The probability distribution of number of televisions per household in a small town. So this is the probability distribution of how many televisions in each house. So part A, find the probability of randomly selecting a household that has 1 or 2 televisions. 1 or 2, I would just add those together, which would be 0.43 when I add those 2 together. Okay, part B, find the probability of randomly selecting a household that has 2 or more. All right, so 2 or more would be these 2. I add them together, which would be 0.88. When I add them together, 0.88. Okay, this one says find the probability of randomly selecting a household that has between 1 and 3 inclusive. Inclusive means it between 1 and 3, but it includes 1 and 3. So I would add all 3 of these, or since that's only one other than, I can do 1 minus that, which comes up to 0.99. Okay, then part D, find the probability of randomly selecting a household that has at most 2 televisions. So they don't have 3, they have at most 2. So we could add these 3 right here. which would be 0.44 if I add them up. Okay, and that's what we do there. See our answers right here, so we're in good shape. All right, 16. Okay, so we've got televisions, number of televisions, the households that have those, and then here's our probability. So like if I add these up right here and then divide each one of those, I'll get these. That's how they get these probabilities. Okay. All right, using the data given below, determine whether it would be unusual for a household to have no HD televisions. Would it be unusual? Well, look at my probability here. 0.030, that's pretty low. If it's below 0.05, we consider that highly unlikely or unusual. So I think it would be unusual. Okay, so it's not this one because it says not. It would be unusual. I think it's B here because that's cut off. But if you look at the answer down here, it says B because the probability of having HD television is less than this amount right here. Okay. Number 17. Okay. This says determine whether the required value of the missing probability to make the distribution a discrete probability distribution. So see, we got one missing here. What would this value have to be for this to be a probability distribution? So basically, I'm just going to add these up that I do know. All right, so 0.17 plus 0.39 plus 0.21, and I get 0.77. So I do 1 minus that. 1 minus 0.77, and there you go. That's going to be 0.23. Okay, you see my answer right there. We're in good shape. So that's not too bad. 18. Determine whether this is a discrete probability distribution. So look at these right here. All right, they're all between 0 and 1, aren't they? Yes. All right, add these up. So this is 0, 1, 3, 6, 7, 8, 9. This is what it adds up to. It's not, because it does not add up to 1. So this is no. It's not a discrete probability distribution. No, because right here, the total probability does not equal 1. Okay. Number 19 here. All right, determine if this is a discrete probability distribution. All right, so let's see all these values here. They're all between 0 and 1. So now if I add them up, all right, I'm going to add these up real quick over here to the side. 1 divided by 20 plus 1 divided by 2 plus 3 divided by 4 plus 1 divided by 100 plus 3 divided by 5 plus 1 divided by 50. All right, so I add these up and look what I get. Oop, I got 1.93. No, it's got to equal 1. So this is a no. And the reason is number A here. The total probability does not equal 1. Okay. Now, next thing we have is we got some variance and standard deviation. And you may not understand this stuff right here, but what we're doing is we're taking each x value minus the mean value, and we're squaring those and timesing it by the probability. All right, so let me show you here. There's an example right here. It's done. Okay, and you don't have, if you don't understand this, that's no big deal having to understand this right here exactly. But here's what we've got. So here's my probability distribution right here. You see 1 has this probability, 2 has that probability, and 3 and 4 and 5, so on. Okay, so what I'm going to do is, all right, when x is 1, here's the probability. Okay, so if I do x minus that, the average, we didn't do the average, did we? All right, so multiply those, multiply those, multiply those, multiply those, multiply those, and add them up. Okay, so let me show you real quick, okay? 1 times 0.16 plus 2 times 0.22 plus 3 times 0.28 plus 4 times 0.20 plus 5 times 0.14. And look what I get there, 2.94. That's my mu. Okay? 2.94, which is what they're saying right here. Mu is 2.94. Okay? So now what you do is after you find the average there, the mean, all right, so you got to do x minus that. So like right here, my x is 1. I'm going to do 1 minus this, 1 minus 2.94, which is negative 1.94. All right. Then I square that. Okay, so I do this times itself. Just hit the square button. And then after I do that, I take this and I multiply it by my 0.16. So let me show you how this works here. Okay, so for number 1 here, I do 1 minus the mean, which is 2.94. And see, I get this negative 1.94 like we said here. All right. Okay, so then I square that. Square that. See, that's this number right here. See that? All right. Then I take this times my probability. So I do that times 0.16. And look there, I get 0.602176. See there? And that's what I do for each one of these. Okay. Then once I do all that, okay, I add all these up, and that's my variance. And of course, if you remember from variance and standard deviation before, once I get that, I do the square root of that, and I get my standard deviation. Okay, and we'll do one here. Okay. So on this one here, I hope it didn't get cut off, because if it is, my answer is going to be wrong. All right, so I'm going to do 0 times this plus 1 times that. See, I'm going to multiply these together and add them all up. So I'm going to do that. I'm going to add these up, and that'd be my mu, my mean. All right, so I'm going to have 0 times 0.675 plus 1 times 0.200 plus 2 times 0.082 plus 3 times 0.024 plus 4 times 0.012 plus 5 times 0.007. And there you go, 0.519. Okay. All right, it says round to 1 decimal place. So 1 decimal place, the 1 does not make the 5 go up at 0.5. And we're in good shape because that's what the answer is. Okay. Now, we want to find our variance. Okay. Now let me do this right here. Okay. I'm gonna make a little. It's probably best if you just do this right here and make a little table for this. All right. So I've got my x, which is 0, 1, 2, 3, 4, 5. Okay. All right. Then I have my probability of x. Okay, which I got 0.675, 0.200, 0.082, 0.024, 0.012, and I got 0.007. So that's these numbers right here. Okay, so there's that. Now the next thing we have is x minus the mu. Okay, now what I do there is, my average we just found is 0.5. So I'm going to do 0 minus that. So 0 minus 0.5 is negative 0.5. Okay, now do 1 minus that. 1 minus 0.5 is positive 0.5. 2 minus 0.5 is 1.5. 3 minus 0.5 is 2.5. 4 minus 0.5 is 3.5. And this would be 4.5. Okay. Now, next thing I do here, I got x minus mu, and I square it. Okay. So right here, you got to put that in parentheses when you do a negative. So it's going to be 0.5, put it in parentheses. Oh, sorry, negative. Left my negative. I'm talking about it, and I left it off. Square it. 0.25. Okay. This would be 0.25 also. This is going to be 2.25, 6.25. This one here, 3.5 squared, 12.25. Oops. And 4.5 square it, 20.25. Okay, so there's your x minus your mu, and then square it. Okay, now you got to do x minus the mu squared, which is what this is, and you got to times it by the probability of x. So basically, I'm going to take this number here, okay, this number here times that number there, okay, all the way down. So in doing this, 0.25 times 0.675. All right, that's going to be 16875. Okay. Now I'm going to do 0.200 times 0.25, and that's going to be 0.05. Okay. Then I got 0.082 times 2.25, and that comes out to 0.1845. All right, then I've got 0.024 times 6.25, and that comes out to 0.15. All right, then I have 0.012 times 12.25, which is 0.147, and then I have 0.007 times this, 0.007 times 20.25, and that comes out to this. Okay, then once I get all these numbers, I just add them up. Okay, so in doing this, 0.16875 plus 0.05 plus 0.1845 plus 0.15 plus 0.147 plus 0.14175. I add all these up, and here's what I get. 0.842. And this right here is my variance. Okay. That's my variance. And now, my standard deviation, I do the square root of that. So my standard deviation, let's just do the square root of that answer. And that's going to be 0.9176. Okay. Now it says on here, and we're good. We got them. It says in there round to the nearest tenth. So see here, 0.8. So the 4 makes the 8 stay. So 0.8 was my variance. The 1 makes the 9 stay. So 0.9. Okay. Now interpret the results of this real life situation. All right. So what that means is, since this is my mean right here, this is my mean. That means a household has an average of 0.5 dogs. So that'd be one of these two right here, with a standard deviation of 0.9 dogs. The answer is a C right here. Okay, that's what this means. The average, this is what the average household has. See, the average household has this, and the standard deviation, which we did here, 0.9, is that, okay? Now, there's another one here. Let's get into it, okay? All right, so let's do this right here. All right, so I'm going to start this out. My x, let's make this come over here. All right. I've got 0, 1, 2, 3, 4, 5. Okay. All right, then I've got my probability of x, which is this right here, 0.264, 0.292, 0.247. Okay. I'm just getting these numbers from up here. 0.133, Then I got 0.045. All right. And then the last one here, I got 0.019. So this is 0.019. All right, there we go. There's my probability of X. Okay. All right, next, I got to take these numbers right here. I got to multiply them and add them together for my mu. See, that's my mean. My mean is the mu. Okay. So let's do 0 times this. So let's push this in. 0 times 0.264 plus 1 times 0.292 plus, all right, 2 times 0.247 plus 3 times 0.133 plus 4 times 0.045 and then plus 5 times 0.019. And I got this my mu right there, 1.46. Okay, there's our average or our mean. Okay, I'm going to cheat, look at the answer, make sure we're right. Okay, you don't want to do something wrong on here. All right, yeah, that's right, because see, it says round it 1 decimal, so the 6 makes the 4 go up to a 5, so 1.5 is my mean. Okay, that's my mean. All right, so since 1.5 is my mean, right here I'm going to do x minus mu. Okay, so I'm going to do 0 minus, now remember 1.5 is my mean, I'll write it right there, okay? So I'm going to do 0 minus this, which is negative 1.5. I'm going to do 1 minus this, which is negative 0.5. I'm going to do 2 minus this, which is 0.5 positive. I'm going to do 3 minus that, which is 1.5. 4 minus that, which is 2.5. And then 5 minus that, which is 3.5. Okay? All right. Not very complicated. Next thing, I'm going to do x minus mu. And I'm going to square it. So I'm just going to take each one of these and square them over here. All right. So negative 1.5 squared would be 2.25. Negative 0.05 is 0.25. And that's 0.25. And these will always be positive because when you square it, it makes it positive automatically. This is be 2.25. This would be 6.25. And this is 12.25. Okay. All right. And now we're up to the last one here. Okay, the last one, I'm going to do my x minus my mu squared. And I'm going to times it by the probability of each x. So basically now, when I do that, I'm going to take these numbers right here and I'm going to multiply them by those numbers right there. So these two, multiply them. And that's what's over here. Okay, so basically 0.264 times 2.25, and that comes out to 0.594. Okay, it'd be good for you to check this yourself, make sure we're doing this right. 0.292 times 0.25, that comes up to 0.073. 0.247 times 0.25 is 0.06175. I add these or multiply these, 0.133 times 2.25, and that is 0.29925. Do these two right here, 0.045 times 6.25. That comes up to 0.28125. And then I do these right here. 0.019 times 12.25. And that comes up to 0.23275. Okay? And now, for my variance, this right here means variance. Okay, that's what this is right here. Oops. This is sigma squared. That's my variance. I just add all these up. Okay, that's supposed to be a sigma there. So just add these up right here. That's my variance. This is a capital sigma. This is a lowercase sigma, just to let you know. I think I said sigma, and then I said sigma for that. All right, so I'm going to add these up. So 0.594 plus 0.073 plus 0.06175 plus 0.29925 plus 0.28125 plus 0.23275. And I add all them up, I get 1.512, and there's my variance right there, which I think it says round at one place, which is 1.5. So the variance is the same as the mean. How about that? And now the standard deviation. All right, just take this right here, and I do the square root of that answer, which is 1.229. 1.229634. This is my standard deviation, which I think it says round one place, I believe. Round one place as needed, it says. Okay, round one place. So this would be 1.2. This 2 makes the 2 stay. So it'd be 1.2. Okay, let's check my answers here. All right, we're good. 1.5, 1.5, 1.2. So we're in good shape. So interpret the results. All right, so the mean is 1.5. See, that's what the mean is right up here. The mean is 1.5. So the average batch of 1,000 machine parts has okay. If you have 1,000 machine parts, you take 1,000 times 1.5. Sorry. That would move over 1. That's going to be 1,550. No. Move that over 1, 1,500. Okay. I don't know what I did. I did something wrong here. Oh, okay. All right. I wasn't paying attention here. The number of defects per 1,000. Okay, that's what I was not understanding. This is per 1,000. So this would be 1.5. The average batch of 1,000 machine parts has 1.5 defects. Or, okay. All right, so right here, number 1, I'm trying to understand what this says here. Blank, the standard deviation is, so, oh, I think, all right, there you go. This has 1 or 2 defects, 1 or 2, according to what you pick here. I was understanding, I thought it was cut off, but it's down here. So this blank goes with this. So this would be 1 or 2 because it's 1.5 defects. The standard deviation is, it's 1.5. So the typical number of defects in a batch of 1,000 is, so the typical number of defects in a batch of 1,000 would be 1.2. That's your standard deviation. Or 1.2 deviations. Okay, so I think, so I guess it deviates from the mean about 1 defect. Okay, about 1 defect. I hope I don't know if I'm explaining this good enough. So the standard deviation is 1.2, which means it fluctuates, it deviates from the mean by about 1 defect. So typically we have 1.5 defects per 1,000, but the standard deviation is 1.2, so this is going to fluctuate, which makes it go up 1.2, which would be 2.7, and it makes it go down 1.2, which would be 0.3. So this is the range that you would expect the defects to be per 1,000. Because if I add my standard deviation to this and subtract it, I get these two values, and that's what it would be between. Okay, Now there's another couple here, or another one. I'm not going to do this last one. This is up for you. But right here, number 23. Just want to talk about 23 here, and I'm finished. And the expected value of an accountant's profit and loss analysis is 0. Explain what this means. Okay. Profit and loss, their expected value, which is their mean, is 0. Their profit and loss is 0, which means they're not making any money, but they're not losing any money. They're breaking even. So I think it's the break-even point, and I believe it's right here, the break-even point. So an expected value of 0 means that the average money gained is equal to the amount of money spent, representing the break-even point. Okay, so there's a lot of stuff in here. We've spent 50 minutes, but this is probably a distribution, section 4.1. If you have questions, let me know. I'll try to help you all I can. And contact me anytime, all right? Have a good rest of the day.